Hi, I'm Caroline, and I'm going to teach you how to simplify and solve circuits with resistors. The first formula you will need to know is known as Ohm's law. Ohm's law states that the electric potential of a circuit is directly proportional to its current, or movement of charge and energy, and its resistance. Potential difference is measured in volts. Current is measured in amperes, and resistance is measured in ohms. Take this circuit for example. The two lines here represent the battery, and the zigzag here represents your resistor. Now, if we gave our battery 2 volts and our resistor 2 ohms, we would be able to solve for our current using Ohm's law. After our calculations, we would find that the current is equal to 1 ampere. However, circuits are rarely this simple. They often contain many resistors which can be placed in one of two ways. The first is known as parallel, which looks like this. In order to combine the two resistances and simplify, you add the reciprocals of both, then take the reciprocal of your answer. For example, if both these resistors had 2 ohms, you would take the reciprocal of the first, 1/2, and add it to the reciprocal of the second, which is also 1/2. To get 1, then take the reciprocal of 1. And your answer would be 1 ohm. Therefore, these two resistors in parallel have the same resistance as a 1 ohm resistor. When in parallel, each branch will get the same voltage. Let's say we gave our circuit 2 volts. Therefore, we have 2 volts right before the resistors. Both branches will get 2 volts. The current will split proportionally for each branch. In this circuit, it will split evenly because there's an equal resistance on your top and bottom. Using Ohm's law, we would see that our current is 2 amperes. This means that we would get 1 amp on top and 1 amp on the bottom. Then, using Ohm's law, we see that our voltage drops by 2 volts on top and 2 on the bottom, which would leave 0 volts. On the other hand, when in series, resistors are much easier to combine. The resistances are simply added together in order to simplify. For example, if these two resistors had 1 and 3 ohms, they would be added to equal 4 ohms. Therefore, these two resistors in series have the same resistance as a 4 ohm resistor. When in series, each resistor gets the same current. Let's take our same resistor as before and give it a 4 volt battery. We know that in order to calculate current, we can use Ohm's law, V equals IR, or 4 volts equals your current times your total resistance, which we found to be 4 ohms. Once we've solved, we find that our current will be 1 ampere. Now that we know current, we can solve for the voltage drop across each resistor. Let's take a look at our first resistor of 1 ohm. Directly in front of this resistor, we have 4 volts. After using Ohm's law, we see that our change in voltage is 1 volt. So the voltage on the other side of the resistor is only 3 volts. Just before our second resistor, we have 3 volts, and when using Ohm's law, we see that the voltage will drop 3 volts, leaving us with 0 volts on the other side. Make sure you hit pause and play so you can solve this next example with me. Now let's put the two together. This circuit contains both resistors in parallel and in series. First, we need to simplify, and we'll start with our parallel resistors. By adding our two reciprocals, we will find that the two are equal to a resistance of 4/3 or 1.33 ohms. Then, we solve in series and get 7/3 or 2.33 ohms. So the three resistors will make a total of 2.33 ohms. Next, we will use Ohm's law to find the current, which is equal to 3 amperes. Now we have everything we need to find the voltage drop across the resistor. So let's go back to our original circuit. We have 7 volts before our resistor, and using Ohm's law with the current that we just found, we are able to solve and find that our voltage drops by 3 volts after passing through the resistor. Each of the resistors in series will have 4 volts beforehand. Now we have to calculate the current. We found that our original current was 3 amperes, so we multiply it by 4/6 to get the current in our top branch, which is 2A. The 4 comes from the bottom branch, and the 6 comes from the addition of the two resistances. Then we do the same for the bottom branch, which is equal to 1 ampere. Now that we have resistance and current, we can calculate our voltage drop across each. Both branches will end up giving you a voltage drop of 4 volts, so you are left with 0 volts. And that's how you solve and simplify circuits with resistors.